One of the most powerful operators in Kotlin on a collection is going to be the map operator. So we have a list of names here. Let's assume that we wanted to take the first three letters of each name, make them uppercase, and make that the abbreviation for the person's name. It's a pretty rudimentary example, but let's go ahead and try to do that. We could use a bunch of different loops to do that, or we can use the map operator. So I'm going to say items.map, and what this allows us to do is pass in a lambda function. And what we can do here is start doing something with. So it is going to be each name in the list. And then we could say substring, we're going to say 0 to 3. So get the first three letters, .to uppercase. Now what this is going to do, map is going to return a brand new list. So it returns a list containing the results of applying the given transformation function to each element in the original collection. Okay, what does that mean? What that means is for each item inside of this list, when we call map, it's going to execute a function. It's basically going to give us that value, and then whatever we do with this value, it's going to return this back. It's going to return whatever the result of this is back. So let's print it off and see what happens here. All this substring is doing is taking the first three letters of the name and making it uppercase. And so as you can see, the result is Don, Jan, Car, Pet, and Claw for the three letters of each of these names up here. Now, I could just completely ignore it and just say foo. Now watch. If I run this, we're going to see foo over and over and over. The reason why, this map, this function is executed every single time. So it's executed for Don Felker, it gets foo. For Jane Doe, it gets foo. For Karthik, it gets foo. For Peter, it gets foo. For Clark, it gets foo. It just executes each individual time. So here I'm just returning these values. So at this point in time, I'm going to get those first three letters. Now we could take this a step further. And we could say, all right, well, we can break this into multiple lines and say, let's say I wanted to get the initials off of everybody. Now there's multiple ways that I could go about doing this. Now what I could do, this is a very naive approach, but it works. I could say it.split, and I want to split this on the space, and now I have some words. And then what I can say is I want to return basically the words, I want the first word, and then I want to substring that one. And that's going to start from 0 to 1. Basically take the first letter of the first word plus words.substring. The second word substring, and take the first letter of that one as well. And so we're going to see here type mismatch. It says found string required unit. So I actually need to just do this. And you may notice, like, why am I not returning it? Because what happens inside of the map is the last value is what's returned inside of this map, which is why it's pointing with an up arrow and it says map inside the IDE. So this is a little hint. It says, hey, this is the return value of the map operation. So now if I were to run this, we're going to see that it's just going to return back the initials, DF, JD, KM, PP, and CK. Now, this is not production quality code. If the user has multiple names and multiple spaces in their name, this is going to fail. If they only have one name, this is going to fail. So this is not production quality, but this just illustrates something that you can do inside of the map operation. So let's go ahead and you rewind this a little bit here and go back to where we were before with the abbreviations. So now I have the abbreviations, right? And just to run it again, you'll see what we have. You have Don, Jan, Car, Pet, Claw. Now, what I might want to do at this point in time is actually go ahead and I can perform another map. I can map over an existing result. I'm just going to move this over here. So now whatever is the result of this, which is Don, Jan, Car, Pet, Claw, I'm going to go ahead and do an operation on that. Now I could map on top of that. So I could say it.length. And we'll return that. Now what you're going to get back is a list of integers, and each one's going to say 3 because each of the abbreviations was 3 long. So that kind of makes sense. Now what I could also do is something like this. I could decide that maybe I want to sum something. I could sum by a particular value, so it.length, and run that. And we're going to see 15. So sum by that. But what does that mean? It means we've taken each of the values here and it's been summed them up into 15. Now I can also decide if I don't want to do a sum, maybe I wanted to do a filter. So remember, this is applying to the result of this map. So I can say filter. I want to get everybody's their first three letters of their name, and then if their first three letters of their name have the letter O in it, so IT, dot contains, so we'll do 2 lowercase just in case. Actually, 2 uppercase. Everything, actually it's already uppercase. So we say it dot contains O. And if we run this, we should only get 1 value back, and that's going to be Don, D-O-N, because I've now grabbed the abbreviation and then I've now filtered it. So I can start stacking these things on top of each other. Now if I, for some reason, would like to reverse these things, reversed, we run that, you're just going to see Don. So let's say contains, and let's go ahead and flip this filter not. So I don't want it if it contains the letter O, which should give me all the other ones. We're going to see CLA, PET, KR, and JAN. Now that's because the array was reversed. I've reversed this array. And I can continue to stack different operations on top of this. So this allows it to be very functional. And so I don't have to perform all of my logic directly within one particular map. I can map from one thing to another thing to another thing. And this allows you to have functions that return perhaps a list of something. And then inside that list, you might perform an operation. And then you might map over that operation and map over something else. It allows you to transform your data in real time, basically as you're typing it. It's much more declarative and easy to read. So that's how you can perform a map operation with just regular primitive types. Now, of course, you can do this with other classes as well. So let's say we have a class called person, and this person has it as a name, which is a string. Let's do something simple like that. And we'll say people. And we'll say list of person Don, and then we say person Jane. Now I have all my people. Well, I can also map right over these people too. So I can say people result. And what this will be is I'll say people.map, and now I'm going to have this IT value as a person. So I can say person.name. I could do something like that. So I can just get everybody's name. Now if I were to print this to the screen, I would say people result. What this is going to give me is a list of strings. It's just going to give me everybody's name. So it's going to be Don, Jane, Bob, Kavita. So I'm just iterating over. I'm just getting a list of that. So it allows me to transform that data, which makes it very, very nice. And of course I can map on top of that, which might be it.length. So I'm going to get the length of everybody's name. And maybe that would be a useful function for me somewhere. I could put this inside of a function and say, all right, give me the length of everybody's names. And it would give back the length of everyone's names accordingly. Now maybe you would want to transform this a little bit further, and you could say, all right, what's the length of their name? And perhaps also I would like to show their, I wanted to include their name as well with that. And then you could create various different mappings and return arrays or arrays of arrays, a list of lists, etc. The possibilities are endless.